Hello everyone. In this video, we're going to be solving an exponential equation. If you like this video, please like, comment, and subscribe. And don't forget to hit the bell button for notifications. And let's get started. Now, we do have 6 minus root 35 to the power x plus 6 plus root 35 to the power x is equal to 142. So this might look like a radical equation, but it's actually an exponential because x is the variable and it's in the exponent. Now, this equation, when you see something like this, first, it might look kind of scary, right? Because x is in the exponent. So these kinds of equations are actually kind of hard to solve sometimes, especially when they're diaphanted. But anyways, we're going to solve this equation for a real solution. Now, what are we supposed to do? The first thing to notice is that if you look at this expression, there's no way we can bring the x down even if you log both sides. So somebody might think, okay, can I log both sides? Okay, I can do that, right? I mean, let's log this expression here, 6 minus square root of 35 to the power x plus 6 plus the square root of 35 to the power x. Now, unfortunately, we don't really have a formula for the log of a sum. We do have the product and the quotient, which turns into sum and difference, but we don't really have anything for this. Well, you might put it together somehow, but it's not going to be really helpful. So in this case, we're kind of stuck. If you try to log both sides, which is typical response. So if I gave you a problem like this, or if you've seen something like this, let's say this is equal to something, let's say 142. Okay, let's use the same number. Then yes, you could log both sides. It would make sense because that would bring the x down and it would work. But in this case, unfortunately, it doesn't. So we have to use a different approach. So what's the idea? Okay, the idea is to notice that there's some relationship between the bases here. And what is that relationship? What is that supposed to mean, right? Well, if you look at the bases carefully, one of them is 6 minus root 35 and the other one is 6 plus root 35. Especially, this will become more clear if you write the 6 as a radical. What do I mean by that? Well, if you go ahead and write down the 6 as the square root of 36, then hopefully this will become more clear. Now you have this expression and you have this expression. Okay, hopefully this will make more sense. Now, notice that these radicals are actually one apart when they're squared. Now, what is that supposed to mean? Well, if you look at these two expressions, they kind of look familiar, right? I mean, what is that called? What's the word that starts with C? Yep, that's conjugate. So these are conjugates. And what is that supposed to mean? It means that if you take these two expressions and kind of multiply together, then you get something nice. What is that supposed to mean? Well, let's go ahead and see what happens. Let's multiply these two expressions together. Square root of 36 minus square root of 35 to the power x multiplied by square root of 36 plus the square root of 35 to the power x. Now, since they both have the same exponent, I can just multiply the insides, and that's going to give me 36 minus 35 to the power x, which means 1 to the power x, and that's equal to 1. Wow, that's nice, right? So not only are these conjugates, but their product is also 1, which is cool. But how can I use that in my expression, right? Their product is 1. Their sum is 142. So that's one way to approach it, right? So you now have two numbers whose sum is 142. So it's kind of like this. If you call this A, and again, I'm kind of using the strategy here of going from one variable to two variables using substitution, but it's going to help us. So in other words, this is what I'm trying to say here. I'm saying that A plus B is 142, okay? And A times B is equal to 1. Awesome. So basically, this is a system of equations, right? And you can solve it. You can turn this into a quadratic. So that's one way to approach it. Another method to approach it is, since the product of these two expressions is equal to 1, right? I can just go ahead and write one of them in terms of the other one. Well, what is that supposed to mean? Well, look at this carefully. You have 6 minus something, and then you have 6 plus something, right? So we have 6 minus square root of 35 to the power x plus 6 plus the square root of 35 to the power x, right? And this sum is equal to 142. Okay, cool. Now, what I'd like to do is, since their product is 1, so let me write that one more time. This times this is equal to 1, as you see. We use the conjugates, right? Okay, this is equal to 1. So what I can do is, I can write the first one in terms of the second one. Like, if you divide both sides by the second expression in the product, so you can write the first one as 1 over 6 plus square root of 35 to the power x. There you go. So how does that help us? Well, now we're going to get a nicer equation because it's going to look like this. 1 over 6 plus the square root of 35 to the power x plus 6 plus the square root of 35 to the power x is equal to 142. There you go. Now, at this point, we have the same expression, but one of them is the reciprocal of the expression. So even if you go by this system of equations, you would pretty much get the same thing because you could replace b with 1 over a or a with 1 over b, so on and so forth. So everybody is pretty much the same thing. So now, what am I going to do? Well, I'd like to use substitution, so I'm going to call this u, okay? And let's see what happens. I get u plus 1 over u is equal to 142, right? Okay. So this turns into a quadratic how? First of all, notice that u cannot equal 0, and obviously it won't because it's a radical expression that's positive, so on and so forth. So we can multiply both sides by u then. Let's multiply everything by u. U squared plus 1 is equal to 142u, okay? What am I going to do next? Well, I'd like to put everything on the same side, obviously. This is going to give me, what? A quadratic equation, right? Cool. Now, this is going to be a quadratic. What am I supposed to do with that? Well, I'm going to solve it, right? So we can solve this quadratic in u. Let's use the quadratic formula, unless you know a way of factoring this, right? Okay, probably hard to factor, so let's go ahead and write the quadratic formula, negative b, right? Plus minus the square root of b squared minus 4ac, which is kind of nice because 4ac is 4 and 4 can be written as 2 squared. Now, how does that help you? Well, it allows you to factor the expression, right? Which is kind of nice. Because as you know, we're trying to get something outside the radical. We always want to be able to factor it for perfect squares. Perfect. Okay, now, this is difference of 2 squares, so it can be written as 142 plus 2, and then 142 minus 2. Not only this is factorable, but also in a nice way, because if you consider 142 plus 2, that's 144. Awesome, right? Because that's 12 squared. Nice. Okay, so let's see what happens. 142 plus minus the square root of. Now I have 144, and here I get 140. Let's see if 140 can it be divided by any perfect squares? Well, it's divisible by 4. So I can write it as 4 times 35, and 35 is 5 times 7. So it's product of 2 primes, can't be really taken outside the radical, but I think we've taken enough. So we should be good. Divide by 2, let's see. Well, this is going to give me a 12. That's going to give me a 2. 12 times 2 is going to be a 24. So I have a 24 outside, right? Awesome. And then inside the radical, what am I getting? I'm getting the square root of 35. Nice. Okay. And then this is, of course, divided by 2. Now, this can be simplified because everything can be divided by 2. So let's go ahead and do that. U is equal to 71 plus minus 12 root 35. Okay, cool. Now, here's the tricky part. Okay, you found the answer, but what is u, right? Well, what did we call u? Well, u is 6 plus root 35 to power x. Okay, cool. So 6 plus square root of 35 to the power x is equal to this. Now, there's 2 things here. First of all, there's a plus sign on the left-hand side. So is there any way we can get a minus sign by raising this number to any integer powers? Why am I saying integer? Because x needs to be an integer, otherwise we can't find it, right? Unless it's a square root or cube root or something like that. Of course, that's possible. Now, so the negative solution is not really going to lead you anywhere. Okay, cool. So what I need to do is then use the positive version, this one. Now, at this point, you can do obviously several different things, but one of the obvious things that to do is just square this number. And when you square this number, okay, when you square this number, you're going to be getting what? Oops, I thought I was going to square it, right? Where does the x come from? If you square this number, and I'll tell you why I'm squaring it, 36 plus 2ab is going to give me 12 root 35. and then plus 35. The reason why I squared it is because of the term 12 root 35. As you know, when you square a plus b, you get 2ab, and I got 2ab in my expression. So that tells me it's a irrational piece that I have to have in there, and I have a rational piece that comes from the a squared and the b squared, and there's some happens to be 71. I mean, this all works out, right? So kind of nice. Well, let's explore what happens if you didn't, you couldn't use this method, or you didn't know what to do. But what I'm trying to tell you is that if x equals 2, then you get the answer, right? Cool. Okay. Now what happens if you get a minus sign, right? Well, we noticed that when I square this number, I get this number. What happens if you square this number? Wow. That's interesting, right? Well, if you square this number, you get the minus version. Well, then there's a way to solve this too, maybe. Oh, yeah, these are reciprocals. There you go. So in other words, I can basically replace 6 minus root 35 with 6 plus root 35 to the power negative 1. That's interesting because they're reciprocals, right? Okay, cool. So these are equivalent. And then raise it to the second power, and then they will be equal. Wow, that's interesting. Well, what is that supposed to mean? It means that this guy over here, 6 plus root 35, raised to the power negative 2, gives us one of the solutions. Awesome. So 2 is not the only solution then. Wow, that's amazing. So we have two solutions. What are they? X equals 2 and x equals negative 2. Now, what would happen if you didn't follow this path and you wanted to do it differently? Well, at this point, your option is you can log both sides, right? Obviously, if you log both sides, you're going to be getting log of this equals log of that, and then you'll be able to bring the x to the front. So you're going to be coming up with something like log of x is equal to, right? Log of this divided by log of that. Okay, so you'll end up with something like this. And guess what? You have to be able to simplify this expression. But how do you simplify it? Again, it all comes down to being able to write this expression as a power of the bottom one. Because if you can do that, we don't really have a rule for log A over log B, but if A is a power of B, then we can definitely simplify it by using the power. Make sense? Hopefully it does. Now, what if that didn't work? Again, we kind of use like trial and error here, and unfortunately, that's what we got to do. But notice the clue that we used is the 12 root 35 is a really good clue for us, right? Therefore, to keep a long story short, and I think I kind of kept it too long, but this is a good point to stop, and let's stop here. And I hope you enjoyed the video. These are the solutions. You can test them out, and you can just go ahead and plug them in, and they should work. Well, thank you for watching. I hope you enjoyed the video. I'll see you tomorrow with another video. And until then, take care and be safe. Bye-bye.